Alright, in this video we're going to be talking about statistical inference, and that's section 6D. This will end chapter 6. And this is going to be one of those topics that we talk about when we're dealing with statistics. Okay? And this is what we call inferential statistics here. The heart of most statistical studies lies within inferring a conclusion about a population from the results for a sample. In this unit, we will briefly explore three important ideas: statistical significance, the margin of error, and hypothesis testing. Okay? Now, let's talk about what statistical significance is. Okay? A set of measurements or observations in a statistical study is said to be statistically significant if it is unlikely to have occurred by chance. Okay? So like in example 1 here, for the following event, state whether you think the difference between what occurred and what you would expect by chance is statistically significant. In this case here, the difference between the expected outcome of getting 266 heads in 300 tosses. Okay? In 300 tosses of a fair coin, you get 266 heads. Would that be statistically significant or not statistically significant? Okay? So, in this case, for us to get a head on a fair coin, that probability would be something like 1 over 5. I mean 1 over 2, because you're only going to get heads or tails. So I'm going to say the probability of getting a head is 1/2. And we're going to talk about probability in the next chapter, by the way. Now 1/2 as a decimal will be 0.5. Here we get 266 heads in 300 tosses. So if I take 266 and divide that by 300, as a decimal, that will be approximately 0.89, which means there was a 89% chance that I got 266 heads in 300 tosses. Now that would be statistically significant, because in this case here, you would expect to get a 50-50 chance of getting heads, even if you did 300 tosses. But here, out of 300 tosses, we got an 89% chance of getting heads. So that would be statistically significant. Alright, example 2. For the following event, state whether you think the difference between what occurred and what you would expect by chance is statistically significant, and explain. Here, an airline with a 92% on-time departure rate has 26 out of 300 flights with late departures. Well, if an airline is on time, has an on-time departure of 92%, then the remaining 8% will have to be late departures. So, in this case, this will be 8% of 300 flights. So if I do 0.08, 8% as a decimal is 0.08, of means to multiply 300. And that would be, in this case, 0.08 times 300. That would give us 24. So we would expect this airline to have 24 late departures. In this case, it has 26 out of 300 flights with late departures. Okay, there's not much of a big difference in the two. So we can say that this will not be statistically significant. Because here the difference between the expected number of late departures, which is 24, and the actual number of late departures, which is 26, can be explained by natural variation. Okay. Now, how can we quantify statistical significance? Okay. There are two common levels of significance. One will be at the 0.05 level, the other one will be at the 0.01 level. Here at the 0.05 level, the probability of an observed difference occurring by chance is going to be 1 in 20 or less. Okay. Now the next page is the other part where at the 0.01 level, the probability of an observed difference occurring by chance is 1 in 100 or less, because 100 is going to be 1 out of 100. Okay. Alright, next I want to talk about what hypothesis testing is. I want to talk about that first. Statistics offer an answer of deciding whether claims are true through a powerful set of techniques for testing the validity of claims. The techniques go by the name of hypothesis testing, and they play a fundamental role in almost every aspect of modern life. Okay? Now, in hypothesis testing, we're going to have two types of hypothesis. One of them will be the null hypothesis. Here, the null hypothesis claims a specific value for a population parameter. It is often the value expected in the case of no special effect. Now, the notation that they use for the hypothesis test would be H sub 0. That would be the notation for the null hypothesis, meaning nothing goes on here. And it takes the form where the null hypothesis, or H sub 0, as they call it, would mean that your population parameter will be equal to the claimed value. And that population parameter could be something like a population mean, or a population standard deviation, or a population proportion. And it always has the equal to sign in it. It's always going to be equal to some claimed value. That will automatically be the null hypothesis. The alternative hypothesis, by the way, is a claim that a population parameter has a value different from that claimed by the null hypothesis. The notation for that would be H sub A. That would be the alternative hypothesis. And if a population parameter has a value different from that claim by the null hypothesis, it's going to have this inequality, either less than, or greater than, or not equal to. It's going to have one of those three inequality symbols that will tell you you have an alternative hypothesis. The equal to sign always will be your null hypothesis. So keep that in mind. Okay, now the outcomes of a hypothesis test. It's going to be either reject the null hypothesis or not reject the null hypothesis. Rejecting the null hypothesis means this: we have evidence that supports the alternative hypothesis. And not rejecting the null hypothesis means that we lack sufficient evidence to support the alternative hypothesis. Okay? Now, sometimes they use this phrase, fail to reject. the null hypothesis. And by the way, if you have to take a statistics class, they're going to use that phrase, fail to reject the null hypothesis, over not rejecting the null hypothesis. Okay? That would be a better phrase for that, meaning that we don't have enough evidence to support the alternative hypothesis. Now, that doesn't necessarily mean that we support the null hypothesis if there's not sufficient evidence here. Okay? Now, our hypothesis test decisions. Let me pull this up. Here we decide the outcome of a hypothesis test by comparing the actual sample statistic, which could be a mean or a proportion, to the statistic expected if the null hypothesis is true. So here, the likelihood or the probability of a sample statistic at least is if the likelihood of a sample statistic at least as extreme as the observed statistic is less than 1 in 100 or 0.01, the result is statistically significant at the 0.01 level. This significance level offers strong evidence for rejecting the null hypothesis and accepting the alternative hypothesis. If the likelihood or the probability of a sample statistic at least as extreme as the observed statistic is less than 1 in 20 or 0.05, the result is statistically significant at the 0.05 level. This significance level offers moderate evidence for rejecting the null hypothesis. Or if the likelihood of a sample statistic at least as extreme as the observed statistic is greater than 1 in 20, the result is not statistically significant and does not provide sufficient grounds for rejecting the null hypothesis. Okay, that's our decision that we make here. Okay. Now let's look at this example here. In a recent study, researchers measured the body temperature of 108 individuals. The mean for the sample was 98.13 degrees Fahrenheit. The accepted value for human body temperature is 98.60 degrees Fahrenheit. If we assume that the mean body temperature is actually 98.60 degrees Fahrenheit, the probability of getting a sample with a mean of 98.13 degrees Fahrenheit or less turns out to be approximately 1 in 1,000. Is this result significant at the 0.05 level and at the 0.01 level? Would it be reasonable to conclude that the accepted value for human body temperature is wrong? And explain. First of all, we're going to start by identifying the hypothesis, both the null hypothesis, which is H sub 0, and the alternative hypothesis, which is H sub A. In this case here, we have to pick which one fits this situation here. Now, you want to keep in mind that your null hypothesis always has the equal sign in it. So we know, well, all of them do have the equal sign in it. But let's see here. In this case, we want the mean of 98.13 or less. Okay? So that tells me this. The accepted is going to be 98.60 degrees Fahrenheit. And it's going to be less than 98.6 degrees Fahrenheit because the mean for the sample was 98.13. So we're going to have to pick the one that has the 98.60 in it for both. it will have to be E. Okay? Because we're assuming that's going to be our claim that the mean body temperature is actually 98.60 degrees Fahrenheit. So it's got to be this. It can't be C, and I know it can't be F or B. Okay. So that's going to be our null hypothesis. The body temperature equals 98.60, and the alternative hypothesis will be body temperature is less than 98.60. Okay. Now, the next part of that question will be, is the result of the test significant at the 0.05 level? Well, let's look at this here. It does say here that the probability of getting a sample with a mean of 98.13 degrees Fahrenheit or less turns out to be approximately 1 in 1,000. That's just as a fraction. But as a decimal, if you do 1 divided by 1,000, you're going to get 0.001. Now, for it to be significant at the 0.05 level, this number has to be less than 0.05. And at the 0.05 level, this number is, that probability is less than the 0.05 level of significance. So here we can say that the test is statistically significant at the 0.05 level because the chance of a sample mean at least as extreme as the observed one is less than 0.05, assuming the null hypothesis is true. And now, is the result of the test statistically significant at the 0.01 level? Well, compare 0.0001 to 0.01. Notice 1 over 1,000 is less than 1 over 100. So again, this is statistically significant at the 0.01 level because the chance of getting a sample mean at least as extreme as the observed one is less than 0.01, assuming that the null hypothesis is true. And then finally, we're going to interpret the results here. Okay, now the test is not, or is significant at both the 0.05 level and 0.01 level. We've already found that out, that it is at both. It is significant at the 0.05 level and the 0.01 level. And it is reasonable, we'll select that one, to conclude that the accepted value for human body temperature is wrong. And the test does offer strong evidence for rejecting the null hypothesis. Okay, because here that test was significant at both 0.05 and 0.01. So we do have strong evidence. Okay, let's look at this next example, example 4. A study of 90 students who took an SAT preparation course concluded that the mean improvement on the SAT was 30 points. If we assume that the preparation course has no effect, the probability of getting a mean improvement of 30 points by chance is 0.06 or 6 in 100. Discuss whether this preparation course results in statistically significant improvement. Use significant levels of 0.05 and 0.01. Well, let's take a look at the first part, identifying the null and the alternative hypotheses. Okay? We're assuming that the preparation course has no effect. That means nothing's going on. So that means the preparation course having no effect will have to be your null hypothesis. Okay? So we know that it can't be A and it can't be C, because it will have to have no effect, and no effect would mean that it will have to be your null hypothesis. Nothing's going on, nothing's changing. Now here we want a mean improvement, so we know it has to improve the score. So that's your alternative hypothesis here. I'm going to choose that answer right there, that your null will be the preparation course has no effect on the score, and the preparation course improves the score. Okay, is the result of the test statistically significant at the 0.05 level? Well, we found that the probability of getting a mean improvement of 30 points by chance is 0.06, or 6 out of 100. Now we're going to compare that to the level of significance of 0.05. Here 0.06, if you compare that, is greater than 0.05, and based on that, that means if your probability value is greater than your level of significance here, that tells us that test is not going to be statistically significant. So here, we talked about this right here, that last bullet point. If the likelihood of a sample statistic at least as extreme as the observed statistic is greater than 1 in 20, the result is not statistically significant. Okay? So, we have to choose answer C right here. The test is not statistically significant at the 0.05 level because the chance of a sample mean at least as extreme as the observed one is greater than 0.05, assuming that the null hypothesis is true. Now, what about at the 0.01 level? That's the next question right here. If we compare what we got for the sample of 0.06 to 0.01, here, that's definitely greater than 0.01. So again, that test would not be statistically significant at the 0.01 level. Here, the chance of a sample mean at least as extreme as the observed one is greater than 0.01, assuming your null hypothesis is true. And now we can interpret these results here. And I'm going to have to continue this on the next page here. Because the choice of answers are here. Now, in this case, the test is not statistically significant, as we found out in both of these. And that's at the 0.05 level and at the 0.01 level. It is, in this case, not reasonable to conclude that the preparation course improves the score. And the test offers, or in this case, does not offer or provide sufficient evidence for rejecting the null hypothesis. Okay? So we can't reject the null hypothesis. But keep in mind, when we can't reject the null hypothesis, we're not saying that the null hypothesis is true. Now here you have to think of criminal cases here. Okay. Person's going to be found guilty or not guilty. If a person is guilty, that means that there was sufficient evidence to convict that particular individual. But when a person is not guilty, that's not saying that he's innocent. That's just saying that the court or the prosecution failed to provide to the court sufficient evidence to convict this individual. So he will be considered not guilty. Okay. Okay, next we'll talk about margin of error. And we're going to go over more of these hypothesis testing examples later on in this video. But now we'll talk about margin of error and confidence intervals. We kind of talked about that in one of the other videos that dealt with confidence interval. Suppose you draw a single sample of size n from a large population and measure its sample proportion. The margin of error for 95% is this formula. The margin of error is approximately 1 divided by the square root of n. Now the 95% confidence interval will be found by subtracting and adding the margin of error from the sample proportion. Okay, so you're going to subtract the margin of error from the sample proportion, and then you're going to add the margin of error to the sample proportion, because a confidence interval is going to be a range of values from the lowest to the highest. There are going to be two endpoints here. You can be 95% confident that the true proportion lies within this interval. The margin of error decreases as the sample size increases. Okay, so keep in mind your confidence interval, which I'm going to label as CI, that's going to be the sample proportion minus the margin of error that's going to be the low limit to the high limit. And to get the high limit, you're going to add the two together, the sample proportion plus your margin of error. Okay. So in example 5, you're going to find the margin of error and 95% confidence interval for the survey result described. In this case here, according to a poll of 1,181 people, about 1/3 or 33% of Americans keep a dog for protection. Okay, so now we want the margin of error and we want the confidence interval in the form of a percent. So the margin of error, to find that out, we use that formula at the top. That'd be approximately 1 divided by the square root of n. So in this case here, it'll be 1 over, now the n in this case is going to be the sample size. In this case, your sample size is going to be 1181. So it'll be 1 divided by the square root of 1181. So in this case here, we're going to do 1 divided by, and then I'm going to do second x squared for the square root, 1181. Hit enter. Now, that's going to be your decimal. But they want it as a percent. So, in the calculator, we need to multiply that value by 100. And let's say we want to round this up to the nearest whole number as they indicated in the example. 2.9 to the nearest whole number will be 3. So the margin of error will be 3%. That goes there. The margin of error will be 3%. Now we're going to use that to find out what our confidence interval is going to be. Okay? We're going to find the lower limit and the upper limit. Okay? That means we take the sample proportion, which is the 33%. So the low limit would be that 33% minus our margin of error, 3%. So 33% minus 3% would be 30%. So the low limit there is 30%. And then the high limit, or the upper limit, if you want to call it that, we're going to add that sample proportion plus the margin of error of 3%. So that high limit is going to be that sample proportion plus the margin of error for the high limit. Again, lower limit, sample proportion minus the margin of error. So now, 33% plus 3% will be 36%. So the confidence interval is from 30% to 36%. Now, if we want to interpret that, we can say that we are 95% confident that the true proportion of Americans that keep a dog for protection falls between 30% and 36%. Okay. All right, here's another example. Find the margin of error and 95% confidence interval for the following study. A survey of 1,895 adults found that 85% of those surveyed support background checks for private and gun show sales. First of all, we need the margin of error and then find the confidence interval. Okay, so in this case, let's find the margin of error first. That's again 1 divided by the square root of n. N is the sample size, so here we're dealing with 1,895 adults. That's your sample size. So it will be 1 divided by the square root of 1,895. So here we do, on the calculator, 1 divided by, 1 divided by, and then second x squared for the square root, 1,895. Now that's a decimal. They want it as a percent, so we'll take that number and multiply it by 100, because anytime you want to convert from a percent to a decimal, you take the decimal portion, multiply it by 100. So here, this will be approximately 2.29, but to the nearest whole number, it will just be, well, actually to the nearest one decimal place in this problem, it'll be 2.3%. So here you have to pay close attention to what they want in that particular problem, how many decimal places they want. Okay. Alright, now for the confidence interval, it's from what percent to what percent? Well, our sample proportion was 85%. So to find the low limit, we take that 85% minus the margin of error of 2.3%. So if I do 85% minus 2.3%, I'm going to get 82.7%. And then for the high limit, or the upper limit, that's going to be the sample proportion of 85% plus the margin of error of 2.3%. If I add those two together, I'm going to end up with 87.3%. Okay, so that's our confidence interval. And if we want to interpret that, that would mean that we are 95% confident that the true proportion of adults who will support background checks for private and gun show sales fall between 82.7% and 87.3%. Okay, and here's one more of these. Here we're going to find the margin of error and 95% confidence interval for the survey result described. In this case, a poll found that 58% of the 1,200 people surveyed believe that Congress should investigate possible Russian interference in the 2016 election, or the 2016 general election. First of all, we need to find the margin of error. Now here the margin of error, of course, just like in the other examples, is going to be approximately 1 over the square root of n. And your n is the sample size. In this case, that's the 1,200 here. So it'll be 1 divided by the square root of 1,200. And I'm using those squiggly marks for approximately equal to, by the way. So in this case, this would be 1 divided by, and then second x squared for the square root of 1,200. Now that's a decimal. Again, they want this as a percent, so we need to multiply by 100. And to the nearest one decimal place here, this will be 2.9%. So the margin of error is 2.9%. Okay, and now we want to find out what our confidence interval is going to be. So here we need to find the low limit first by taking the sample proportion of 58% and then minus our margin of error, 2.9%. So subtract 2.9% from 58%, you're going to get 55.1%. That will be the low limit. And now for the high limit. We take the 58% and we're going to add to it the 2.9% to get that upper limit. Adding 58% to 2.9%, you're going to get 60.9%. So here our confidence interval is from 55.1% to 60.9%. That means that we are 95% confident that the true proportion of people surveyed who believe that Congress should investigate possible Russian interference in the 2016 general election falls between 55.1% and 60.9%. Okay, now let's go back to some of those hypothesis testing problems here. Here's some examples. Here we're going to do the following for the case below. We're going to state the null and alternative hypothesis for a hypothesis test. Excuse me. And B, describe the two possible outcomes of the test using the context of the given situation. In this case here, the governor claims that the percentage of adults over 25 who have graduated from high school is greater than 88%, which is the national average. So now we want to find out which one of these choices in part A is the null hypothesis. Now keep in mind the null hypothesis will always have the equal sign in it, no matter what. Oops. So here we want to find out which one of these would best fit the null hypothesis. And in this case here, the null hypothesis would have to be choice B, where the percentage of adults over 25 who have graduated from high school is 88%. And then what is the alternative hypothesis? It's either going to have the less than or greater than or not equal to. Keep that in mind. It's either less than or greater than or not equal to. In this case here, the claim was that the percentage of adults over 25 who have graduated from high school is greater than 88%. And it will have to be choice B. Okay, that will be the alternative hypothesis. Okay, that's part A, identifying the null and alternative hypothesis. Now part B, what is the outcome if the null hypothesis is rejected? So if we reject the null hypothesis, that would mean we have to support the alternative hypothesis. Okay? So in this case here, we have to say that there is evidence that the percentage of high school graduates exceeds 88%. And the word exceeds means greater than. Okay? Because we're rejecting the null where we say that the percentage of adults over 25 who graduated from high school is 88%. That's the null. We reject that and support the alternative hypothesis. But what will be the outcome if the null hypothesis is not rejected? Okay? Well, if we don't reject or we fail to reject the null hypothesis, then we're saying that there's not enough evidence to support the alternative. There's not enough evidence to conclude that the percentage of high school graduates exceeds 88%. Okay, let's look at another example. Continue on with our hypothesis testing problems here. The Food and Drug Administration claims that the amount of vitamin C in tablets produced by a company is less than the advertised 500 milligrams. So here we want to consider that claim related to a statistical study and answer parts A and B. And in part A, we're going to state the null and alternative hypothesis for a hypothesis test. Keep in mind the null has to have the equal sign in it. So we know we can eliminate A and B from these choices of answers that we have here. Okay? So it's either C or D. Now, it does say here that the amount of vitamin C in tablets produced by a company is less than 500 milligrams. So we want the one that's strictly less than 500. It would have to be this one right here. Okay? So we have to choose that one. We have to eliminate D, because in the alternative, you could only have either less than, greater than, or not equal to. Here we got greater than or equal to. That would not be in a alternative hypothesis. So it's going to be answer C in this case. Okay, now part B is to describe the two possible outcomes of the test using the context of the given situation. Let's see. If we reject the null hypothesis, here's our null hypothesis that the vitamin C in tablets is 500 milligrams. If we reject that null hypothesis, that means we're going to support the alternative hypothesis that the vitamin C in tablets is less than 500 milligrams. Okay? So here, I know we can eliminate, I know I can eliminate A, because rejecting the null hypothesis does not mean that there's insufficient evidence. The same thing with B. It will have to be either C or D. Now let's talk about what happens if we fail to reject the null hypothesis. If I fail to reject this, then that means I can't support the fact that, I can't support the alternative. Okay? So it has to be D. And you kind of have to read over this, by the way. Because if we fail to reject the null hypothesis, that means that there is not enough evidence, or there's insufficient evidence to conclude that the tablets contain less than 500 milligrams. So it have to be choice D in this case. Okay, the next example would be this. Here, the following exercise describes the results of a hypothesis test in terms of the probability of obtaining a particular sample. Use a given context to formulate the null and alternative hypothesis. Then discuss whether the sample provides evidence for rejecting or not rejecting the null hypothesis. Alright, in this case here, the owner of a rental car company claims that the mean annual mileage for a population on all cars in his fleet is more than 11,765 miles, which is the mean annual mileage for all cars in the country. A random sample of N is equal to 220 cars from his fleet have a mean annual mileage of 12,065 miles, assuming that the mean annual mileage for all cars in his fleet is 11,765 miles. The probability of selecting a random sample of this size with a mean annual mileage of 12,065 miles is, or more, is 0.0082. Now here you're going to formulate the null hypothesis. Well, the null hypothesis will have to have the equal sign in it regardless. Okay? Now, his claim is right there in that first sentence, saying that the mean annual mileage for a population of all cars in his fleet is more than 11,765. Okay? So we can't use A and we cannot use C because it has the 12,065. That comes from a sample. Okay? So in this case here, it'll have to be B. It can't be D because it says is not. And the null has to say is. And the word is means equal to. And then your alternative hypothesis, well, I just say more than, which means greater than, by the way. And it'll have to be greater than 11,765 miles, so it has to be is or D. Because here I'm interpreting what that first sentence says in that particular claim for the owner of that rental car company. So that's your null and that's your alternative hypothesis. Okay. Next we'll look at this part. Discuss whether the sample provides evidence for rejecting or not rejecting the null hypothesis, and choose the correct answer below. Now I did say that the probability of selecting a random size with a mean average less than, of 12,065 or more, I'm kind of paraphrasing here, that would be 0.0082. that was given to us in that particular problem, as you can see here. The probability of selecting a random sample of this size with a mean annual mileage of 12,065 or more would be 0.0082. Okay. Now, if we compare that to this 0.05 and 0.01, here 0.0082 is definitely less than 0.005, 0.05 I mean, and also 0.0082 is also less than 0.01. Okay, so here it is statistically significant, so here we can say based on that the test does offer strong evidence for rejecting the null hypothesis, because that probability value here that they gave us is less than 0.05 and less than 0.01 as well. So we do have strong evidence for rejecting the null hypothesis. Okay. Here's the next example. A hospital administrator finds that the mean hospital stay for a sample of 73 women after childbirth is 2.5 days. She claims that the mean stay at her hospital is greater than the national average of 2.2 days, assuming that the average at her hospital is the same as the national average. The probability of observing a sample with a mean of 2.5 days or more would be 0.12. Formulate the null and alternative hypothesis. Then discuss whether the sample provides evidence for rejecting or not rejecting the null hypothesis. Assume a significance level of 0.05. So now we're going to identify the null and alternative hypothesis. Alright, let's look at that claim. It says that she claims that the mean stay at her hospital is greater than the national average of 2.2. Well, find the one that says greater than 2.2. It will have to be this one. We know that's got to be the alternative hypothesis. That's the inequality symbol for greater than. Your null will have to have the equal to symbol in it. So it has to be choice D in this case. Okay. Alright, next. Is the result of the test statistically significant at the 0.05 level? Okay, in this case, that probability value that they gave us, the probability of observing a sample with a mean of 2.5 days or more is 0.12. And we're testing this at the 0.05 level. Compare those two. 0.12 is greater than 0.05. So that means, in this case, that test cannot be statistically significant because the probability value that we got from that sample was greater than the level of significance of 0.05. So here the test will not be statistically significant at the 0.05 level because the chance of a sample mean at least as extreme as the observed one is greater than 0.05, assuming the null hypothesis is true. Okay. And then next, determine if the null hypothesis should be rejected. Well, since the test is not statistically significant at the 0.05 level, that means we cannot reject the null hypothesis. Okay? Because the chance of the sample result was greater than the significance level. So it'll be that answer choice there. Okay. And finally, example 12. Hopefully I can get all this on the screen. The following exercise describes the results of a hypothesis test in terms of the probability of obtaining a particular sample. Use a given context to formulate the null hypothesis and alternative hypothesis, then discuss whether the sample provides evidence for rejecting or not rejecting the null hypothesis. Okay, each baseball in a random sample of 35 new balls is dropped onto a concrete surface and the bounce height is recorded. The heights have a mean of 91.87 inches. A statistically literate manager claims that the mean bounce height for all baseballs is 90.59 inches, and the likelihood of observing a sample mean of 91.87 inches would be 0.0336. Let's formulate the null hypothesis. Okay. Now, the claim was that the mean bounce height for all baseballs is 90.59 inches, so that will have to be the null hypothesis, because the word is going to be here equal to, and the null hypothesis always has equal to in it. So here we're going to have to choose answer choice B, where the mean bounce height of baseballs is 90.59 inches. And then formulate the alternative hypothesis. Here we're going to choose the correct answer here. Let's see here. We're going to be dealing with the fact that the sample mean that he got was greater than the claimed amount. Okay. So here we're going to say that the mean bounce height of the baseballs would be greater than 90.59 inches. Okay. So that's going to be answer C. Now again, you have to read through those carefully to find out which will best fit the alternative hypothesis, also with the null hypothesis as well. Now you're going to discuss whether the sample provides evidence for rejecting or not rejecting the null hypothesis. And we're going to choose which one would fit. Now we're told that the likelihood of observing a sample mean of 91.87 inches was 0.0336. We're going to compare that to the 0.05 level of significance and the 0.01 level of significance. Well, if I compare 0.0336 to 0.05, that 0.0336 is less than 0.05, so we know the test does offer evidence at the 0.05 level. But what about the 0.01 level? Here, 0.0336 this time is greater than 0.01. Okay, so we can see here that it offers evidence at the 0.05 level, but not at the 0.01 level for rejecting the null hypothesis. So it'll be this answer choice right here. Okay. Because this probability value here will have to be less than 0.05 and also have to be less than 0.01 for us to have strong evidence of rejecting the null hypothesis. Now, if this was greater than 0.05 and also greater than 0.01, then there is not sufficient grounds for rejecting the null hypothesis. Okay. So that will conclude this particular video on statistical inference, which is one of the other parts of the statistics that we talked about in general.